Здається, нарцис у команді – це токсична людина, від якої страждають інші. Дослідження тисячі працівників із Польщі показало зворотне. Саме нарцисам в етичній компанії гірше за всіх. Вони вигорають першими від необхідності грати в турботу. У цьому відео ти дізнаєшся, чому людям з темною тріадою важко в хороших місцях, як caring climate перетворюється на пастку для макіавелістів, чому нарциси злять сильніше за психопатів, і що це означає для твоєї команди або для тебе особисто. Через 5 хвилин ти зрозумієш, чому етична культура іноді працює як вигонятель токсичних людей. Але спочатку давай розберемося, що таке темна тріада і чому вона не діагноз. Темна тріада – це психологічна конструкція 3 рис особистості. Її вперше описали Делрой Паулюс і Кевін Вільямс у 2002 році. До неї входять нарцисизм, макіавелізм і психопатія. Важливо, це не психічні розлади. Це субклінічні риси. Простіше кажучи, людина може мати ці риси, але не бути психічно хворою.
Ships sailing in the Java Sea, hundreds of miles from Sumbawa, reported hearing what they thought was distant cannon fire. But in Europe, where the consequences would prove catastrophic, nobody heard a thing. The sound didn't travel that far, and news moved only as fast as sailing ships could carry it. By the time European newspapers mentioned a distant eruption in the East Indies, the debris was already circling the globe in the stratosphere, preparing to dim the sun itself. The secret to Tambora's global impact wasn't just the size of the eruption, but where the debris ended up. Most volcanic material falls back to Earth within days or weeks, causing local devastation but little else. Tambora was different. The sheer violence of the blast propelled millions of tons of sulfur dioxide and ash into the stratosphere, the atmospheric layer that sits above normal weather patterns between 10 and 50 kilometers above the Earth's surface. Up there, the sulfur dioxide mixed with water vapor to form tiny droplets of sulfuric acid, creating what scientists now call a sulfate aerosol veil dome. These microscopic droplets are exceptionally good at one thing: reflecting sunlight back into space before it can warm the planet below. Within months, this veil had spread around the entire globe, carried by stratospheric winds that circle the Earth far above the clouds. The effect was like hanging a translucent curtain between the planet and the sun. Sunlight still got through, so it wasn't dark, but significantly less solar energy reached the surface. Temperature records from Europe and North America show that the veil reduced incoming solar radiation by enough to drop global temperatures by an estimated 0.4 to 0.7 degrees Celsius. That might sound trivial until you realize that most of human civilization exists within a temperature band of just a few degrees. The difference between a good harvest and mass starvation can be less than 1 degree sustained across a growing season. But global averages only tell part of the story, because some places got hit far worse than others. The year 1816 remains, to this day, the coldest year in the entire span of documented meteorological records. Temperature measurements from weather stations across Europe and North America show consistent anomalies throughout the spring and summer months. In normally temperate regions, the patterns were simply bizarre. Switzerland experienced blood-red snowfall in March, the snow colored by residual volcanic dust still settling from the stratosphere. Britain saw brown snow. In May, frost struck across New England on a nearly nightly basis. June brought what should have been impossible: a hard freeze across the northeastern United States and eastern Canada. Quebec City recorded snow on the 10th of June. Parts of New England saw snow every single month of 1816, including the summer months, something that had never been recorded before and hasn't happened since. The atmospheric phenomena were equally strange. Persistent dry fogs hung over the northeastern United States and parts of Europe throughout the spring and summer, fogs that weren't quite like normal fog. They didn't burn off in sunlight. They dimmed the sun to a pale reddish disk and left a strange, acrid taste in the air. People didn't know it, but they were breathing the remnants of Mount Tambora volcanic aerosols that had circled the globe and now hung stubbornly in the lower atmosphere. In Connecticut, temperatures swung wildly, sometimes dropping 20 degrees Fahrenheit within hours. One farmer recorded 83 degrees on the 9th of June, then 29 degrees on the 10th. The very concept of seasonal predictability, which agriculture depends upon absolutely, had simply broken down. The agricultural consequences were catastrophic across the entire northern hemisphere. Crops that had been planted in April and May, following normal seasonal patterns, simply froze in the ground. Killing frosts in June destroyed much of the corn crop across New England and the mid-Atlantic states. Wheat, more cold-tolerant than corn, survived in some areas but produced yields far below normal due to the shortened, cooler growing season. In July, when farmers desperately replanted hoping for a late harvest, frost struck again. Some areas of New England experienced hard freezes in every single summer month, making agriculture effectively impossible. Vermont saw corn frozen solid on the 4th of July. By August, it was clear that harvest failures were going to be widespread. In Europe, the situation was equally dire and complicated by the fact that the continent was still recovering from the Napoleonic Wars, which had ended only the previous year. Food reserves were already low. Switzerland, trapped between alpine weather systems that magnified the cooling effect, was hit particularly hard. Crop failures led to food riots in several Swiss cantons. France saw bread prices spike dramatically as wheat harvests failed across the northern regions. Ireland, heavily dependent on oats and potatoes, experienced significant crop losses, a grim preview of the even more catastrophic potato famine that would strike 3 decades later. In Germany, food prices rose so high that desperate people resorted to eating cats, dogs, and even making bread from sawdust and moss. The global nature of the crisis meant there were no surplus regions to import food from. Everyone was struggling simultaneously. The human cost of these failures went far beyond empty stomachs, and Americans gave the year a nickname that captured just how deadly it became. Americans called 1816 by a name that left no room for ambiguity. 1800 and frozen to death. The nickname was grim, but accurate. Mortality data from New England and eastern Canada show significant spikes in deaths during 1816 and the following winter. Malnutrition weakened immune systems, making people more susceptible to diseases like typhus and tuberculosis. Children and the elderly died at elevated rates. Livestock, unable to graze on frozen or non-existent pasture, starved or had to be slaughtered early, leaving farm families without animals for the following spring. The economic devastation triggered one of the largest internal migrations in early American history. Thousands of New England farm families, facing the prospect of another potentially catastrophic growing season, simply abandoned their land and headed west. The population of Vermont actually declined as families packed what they could carry and moved toward the frontier territories of Ohio, Indiana, and Illinois, seeking land where the climate might be more reliable. The westward migration of 1816 and 1817 fundamentally reshaped American demographics. Towns in Vermont and New Hampshire were partially abandoned. In Canada, similar patterns emerged, with families moving from the maritime provinces toward Upper Canada and beyond. The total death toll from the year without summer is difficult to calculate precisely because record-keeping was inconsistent, and deaths from malnutrition and diseases are hard to attribute directly to climate. Conservative estimates suggest tens of thousands died across Europe and North America, with the global toll potentially exceeding 100,000 when including deaths in Asia, where monsoon failures linked to the same atmospheric disruption caused famines in China and India. In June of 1816, while farmers across New England watched snow destroy their crops, a group of English writers were trapped indoors at a villa on Lake Geneva in Switzerland. The weather was so persistently cold and gloomy that outdoor activities were nearly impossible. Among the group were the poet Lord Byron, the physician John Polidori, and an 18-year-old woman named Mary Godwin, who would later become Mary Shelley. Day after day, they sat inside as rain drummed on the windows and unseasonable cold kept them from the summer activities they'd planned. Bored and restless, Byron proposed a challenge. Each person would write a ghost story. Mary struggled with the assignment for days, unable to think of a plot. Then late one night, following a conversation about galvanism and the possibility of reanimating dead tissue, she had a waking nightmare. She envisioned a pale student of unhallowed arts kneeling beside the thing he had put together, a hideous corpse brought to life. From that vision came Frankenstein, or the modern Prometheus, published 2 years later, and destined to become one of the most influential works of Gothic literature ever written. The novel explores themes of creation, responsibility, and the consequences of playing God. Themes that resonate differently when you realize the book was written during a year when nature itself seemed to have turned hostile and unpredictable. Without Tambora dimming the sun, there would have been no dark summer at Lake Geneva. Without the dark summer, no ghost story challenge. Without the challenge, possibly no Frankenstein. A volcano in Indonesia created the conditions for one of literature's most enduring monsters, which is the kind of butterfly effect that makes you wonder what else is connected in ways we don't yet see. Perhaps the most important legacy of 1816 wasn't literary or even humanitarian, but scientific. Before the year without summer, most people thought of weather as a purely local or at most regional phenomenon. The idea that an event on one side of the planet could affect climate on the other side was not widely accepted. The global scale and simultaneity of the 1816 crisis forced a conceptual shift. Scientists and observers began to recognize that atmospheric patterns connected distant parts of the world in ways that weren't immediately obvious. Ironically, it took decades before anyone definitively connected the cold summer to Tambora. The eruption had been reported in European newspapers in 1815, but the idea that volcanic debris could affect global climate for over a year seemed implausible to most scientists of the era. It wasn't until later in the 19th century, after more volcanic eruptions and better atmospheric science, that the connection became clear. The 1816 event became a crucial data point in understanding how volcanic eruptions influence climate. Modern climate science can look back at 1816 and use it to calibrate models of atmospheric aerosol behavior, which in turn helps us understand both volcanic risks and other forms of atmospheric intervention. The year without summer taught humanity that the atmosphere is a single connected system, that events have consequences across vast distances, and that the thin envelope of air we live in is far more fragile and interconnected than it appears. Those lessons remain relevant today, as we conduct a rather larger experiment with atmospheric composition, and hope the results will be less catastrophic than what one Indonesian volcano managed in 1816. The year 1816 stands as a stark reminder that we live on a geologically active planet with an atmosphere far thinner and more vulnerable than we usually consider. A single volcano, erupting for just a few days on a remote island, managed to disrupt global climate for more than a year, killing crops across 2 continents and starving over 100,000 people. It gave us Frankenstein, triggered one of the largest migrations in early American history, and taught scientists that weather is a global system that connects us all whether we like it or not. Mount Tambora itself is still active. So are dozens of other volcanoes around the world capable of similar eruptions. We can't prevent them. We can barely predict them. What we can do is remember 1816 and understand that the difference between a normal year and a catastrophic one can be as simple as the right mountain exploding at the right time. The next time you enjoy a warm summer day, maybe take a moment to appreciate that the sky is currently cooperating. It doesn't always. Take a look at your local weather patterns this week and consider how much of your daily life depends on them staying normal.